In this video, I'll be discussing the 2010 AMC 10A problem question number 19. Equiangular hexagon ABCDEF has side lengths AB equals to CD equals to EF equals to 1, and BC equals to DE equals to FA equals to R. The area of triangle ACE is 70% of the area of the hexagon. What is the sum of all possible values of R? So we have an equiangular hexagon ABCDEF, meaning that angle A equals to angle B equals to angle C equals to angle D equals to angle E equals to angle F. And then this angle will equal to 120 degrees. This is because the exterior angle of a hexagon is going to be 60 degrees because 360 divided by 6. So each angle is going to be 180 minus 60, 120 degrees. And then we know that AB equals to CD equals to FE equals to 1, BC equals to D equals to AF equals to R. And then triangle ACE. So triangle ACE's area will be 7/10 of the area of the hexagon. But the question is, how do we find the area of the hexagon and the triangle ACE? We want to do this in order to get some relationship between R. Well, for the hexagon, you see, when we have 120 degrees, well, there's almost always a chance to get an equilateral triangle because there's going to be 360-degree angles. So let's try that. Extend CD FE CD AB AB and FE. So we can mark this one G, H, and I. And these will actually equilateral triangles. And I will show you how. Okay. So, since ABCD EF is equiangular, so angle BAF equals to angle B equals to angle BCD equals to angle D equals to angle DEF equals to angle F. And this will equal to, well, the formula for the sum of the angles of a hexagon is n minus 2 times 180 degrees. So it will be 6 minus 2 times 180 degrees divided by 6. And this will equal to 4 times 180 degrees divided by 6, which is 4 times 30 degrees. So that'll be 120 degrees. Okay. Now, extend AB and CD to intersect at G. Extend AB and FE to intersect at I, and extend CD and FE to intersect at H. Okay, so from this helping line, we can get, since angle IAF goes to angle IFA equals to angle DEH equals to angle EDH equals to angle GCB equals to angle GBC, and these will all equal to 180 degrees minus 120 degrees equals to 60 degrees. So we can get that triangle GBC, triangle EDH, and triangle AIF are equilateral triangle. So AI equals to IF equals to EH equals to DH equals to GB equals to GC equals to R. Because we know that their bases are going to be AF, BC, and ED, and they all have length of R. So we can then get, now since angle G equals to angle H equals to angle I, so triangle GIH is equilateral triangle. Equal to 60 degrees. So IG equals to IH equals to GH equals to 1 plus R equals to 2R plus 1. Okay. And now we shall use an important formula, the area of equilateral triangles. So we can find the area of the hexagon. A, B, C, D, E, F equals to A triangle GIH minus 3 times A triangle GBC. It can be any of the 3 small equilateral triangles because they are congruent, which will equal to, the area of an equilateral triangle is square root 3 times 4, no, square root 3 over 4 times S squared, where S is the side length. Okay, square root 3 over 4 times 2R plus 1 squared minus 3 times square root 3 over 4 R squared. Then, okay, so we know the area of ABCDEF. Now, to the hard part of this problem is going to be find ACE. Okay. So how do we do that? Since we shall prove some congruent triangles, AB equals to CD equals to FE equals to 1, angle B equals to angle D equals to angle F equals to 120 degrees, and BC that equals to ED equals to AF equals to R. So triangle ABC congruent to triangle CDE congruent to triangle EFA by SAS. So AC equals to CE equals to AE. So we can get that triangle ACE is equilateral. Now we have to use the law of cosines. So the law of cosines, what is it? Well, here, I can write it in the above section. Law of cosines. This will equal to, so let AC equal to, you know what, fine. AC squared equals to 1 squared plus r squared plus, minus 2bc cosine A. Well, I mean, A in this case will be 120. If I'm a more general one, well, here it is. Say you have this triangle. Then A, B, C. So, and mark these C, B, A. Then, this will, then if you want A, and you already know B and C, so it will be A squared equals to B squared plus C squared minus 2BC cosine A. And that is how the law of cosine works. And cosine is a trigonometric topic. Cosine equals to, the cosine of an angle equals to, in the right triangle, the opposite side of the angle over the hypotenuse. Okay, running out of space, so I won't write the cosine definition. So we have here AC squared equals to 1 squared plus r squared minus 2, and here BC will be r, 1 times r, minus 2r times cosine 120. Well, here is another important concept. Cosine 180 degrees minus theta equals to cosine theta. So in this case, we will get that cosine theta will be, well, 180 degrees minus theta will equal to 120 degrees. So theta will equal to 60 degrees. So cosine 120 equals to, this is going to be negative theta. Negative cosine 60. And you know that cosine 60, this is a value you should remember. Cosine 60 will equal to 1/2. So cosine 120 equals to negative 1/2. Okay. I'm going to do a quick reasoning on why cosine 60 equals to 1/2. So we have a triangle here, A, B, C. A, C, B, okay. Well, let angle B equal 90 degrees, and then angle A equals to 60 degrees from the given condition, so angle C equals to 30 degrees. And what have we here? Well, we have, obviously, a 30, 60, 90 right triangle. And then 30, 60, 90 right triangle, the ratio of the sides are going to be 1 to square root 3 to 2. So there will be 1 to square root 3 to 2. And cosine, cos equals 2. So if I say cosine A, cos A will equal to the adjacent side, A over H. So cosine A equals to A over H. So that would be 1 over 2. So that is why we get cosine 120 equals to negative 1 over 2. So it will be times negative 1 over 2. So then this equal to 1 squared plus r squared minus 2r times negative 1 over half. And so the negative signs cancel out. So it will just going to be plus r. So r squared plus r plus 1. And we don't need to find AC squared because A triangle ACE equal to square root 3 over 4 times r squared plus r plus 1. Okay. Now, we can use this condition that the area of triangle ACE is 70% of the area of ABCDEF. So, (7/10) because 70% times square root 3 over 4 times 2r plus 1 squared minus 3 times square root 3 over 4 r squared equals to square root 3 over 4 times r squared plus r plus 1. Now, we can cancel out the square root 3 over 4 on both sides. We can get 7/10 times 4r squared plus 4r plus 1 minus 3r squared through r squared plus r plus 1. So this will be 7/10 r squared plus 4r plus 1 equals to r squared plus r plus 1 times 10 on both sides. 7r squared plus 28r plus 7 equals to 10r squared plus 10r plus 10. So then you can get 3r squared minus 18r plus 3 equals to 0. Simplify that, and then you can get that r squared minus 6r plus 1 equals to 0. Okay, and now we shall use a very common algebra topic, Vieta's formula. I covered that in another video. So, I'm going to write that by Vieta's formula the sum of roots are equals to negative b over a, which equals to negative 6 over 1, which equals to 6. So 6 is going to be the answer of the question, E. Okay, now, just to recap quickly here, this is a very challenging problem involving trigonometry. So the first step was the helping lines, which is always crucial to solving problems, especially geometry. And then, of course, exterior angles. So we have to know this. The number of degrees in each angle because it equals angular. And for equilateral triangle, you can find the area of ABCDEF. Then we can prove out ACE is equilateral. And then using the law of cosines here, very important topic. And then we can find out the length of AC squared. Also, we can use a reduction theorem, which is cosine 180 degrees minus theta equals to cosine theta. So cos 120 equals to negative 1/2. So we found out AC squared equals to r squared plus r plus 1. And then using the area of a equilateral triangle formula, I can say here again, equilateral equals to square root 3 over 4 times s squared. So we found out the area of ACE. Then for some cancellation, we get r squared minus 6r plus 1. Then using Vieta's formula, we can get that sum of roots r equal to 6. And that is how you solve this problem. Thank you for watching.